Long after the final galaxies fade and the last stars burn out, the universe will enter a strange era, unlike anything we know today. For billions of years, stars have been the engines of light, warmth, and creation. They forge the elements, illuminate galaxies, and shape the structure of the cosmos. But stars are not eternal. Every star eventually runs out of fuel. When the very last one dies, the universe will fall into a deep cosmic darkness where no new light is born again. Astronomers call the distant future after the last stars the degenerate era. In this time, the universe will no longer shine with bright stellar light. Instead, it will be filled mostly with stellar remnants, white dwarfs, neutron stars, and black holes. These objects are the corpses of once brilliant stars. They no longer produce energy through fusion, yet they remain as silent witnesses to a universe that was once filled with blazing suns. White dwarfs will slowly cool for trillions upon trillions of years. At first they glow faintly, radiating the leftover heat from their past lives, but eventually even that warmth fades away. Over unimaginable spans of time, these stellar ambers will cool into black dwarfs, cold and invisible objects drifting through the void. By this time the universe will be unimaginably dark, with only faint gravitational interactions breaking the silence. Neutron stars, the collapsed cores of massive stars, will also slowly lose their remaining energy. Once they spin rapidly and emit powerful radiation across the cosmos. In the far future, they too will fade into quiet, cold spheres of ultradense matter, without fresh stars being born. The universe becomes a graveyard of ancient stellar remains drifting through ever-expanding space. The black holes will dominate the future universe more than anything else. These objects grow when stars collapse or when galaxies merge. Over cosmic time, black holes will swallow surrounding matter, dust, and even other stars. Eventually, most of the remaining matter in galaxies will be captured by them. In the distant future, black holes may become the last major structures left in the universe. Even black holes, however, are not eternal. According to theoretical physics, they slowly evaporate through a process called Hawking radiation. This phenomenon was first proposed by physicist Stephen Hawking. It suggests that black holes gradually lose mass by emitting tiny amounts of energy. For small black holes the process is faster, but for supermassive ones it could take unimaginable timescales. The largest black holes at the centers of galaxies may survive for up to 10 years or longer. That number is so large it is difficult to comprehend. During this era, the universe will be almost completely empty and cold. Black holes will sit in isolation, slowly losing mass, while the rest of the cosmos stretches further apart due to cosmic expansion. Eventually, even the last supermassive black hole will evaporate completely. When that happens, the universe will enter what scientists call the dark era. At this stage, there will be almost no complex structures left. No stars, no planets, no galaxies, only thin particles of radiation and the occasional lonely subatomic particle, moving through endless darkness. In the dark era, time itself begins to lose meaning in the way we understand it. Events become incredibly rare. Collisions between particles might occur only once in trillions of years. The universe becomes quiet beyond imagination, with almost nothing left to interact or evolve. Despite the emptiness, the universe will still follow the laws of physics. Gravity, quantum mechanics, and cosmic expansion will continue shaping the faint remnants of matter and energy. However, the scale of these changes becomes so slow that from any human perspective the universe would appear completely frozen. Some scientists speculate that strange events might still occur during these vast timescales. Quantum fluctuations could occasionally create particles out of empty space. These tiny bursts of energy would appear and vanish almost instantly, like brief sparks in an otherwise silent and dark cosmos. There is also a theoretical possibility that protons themselves may eventually decay. If this happens, even ordinary matter will not survive forever. Over unimaginable spans of time, atoms could break apart into lighter particles, leaving the universe filled mostly with radiation and extremely simple forms of matter. If proton decay occurs, the universe would slowly dissolve into a thin soup of elementary particles. Everything that once formed galaxies, stars, and planets would gradually disappear. The grand cosmic structures that shaped the universe for billions of years would fade into near nothingness. Another possibility is that quantum fluctuations might occasionally create brief, temporary structures even in the dark universe. Tiny regions of energy could form particles, even microscopic black holes for a moment, before vanishing again. These rare events would be among the only signs of activity in otherwise silent cosmos. Some cosmologists even suggest that entirely new universes might someday emerge from quantum processes in this empty space. These baby universes would expand separately from our own, carrying their own laws of physics and cosmic histories. If true, the death of our universe might not be the end of cosmic creation. So what happens after the last star dies? The universe does not suddenly end. Instead, it slowly fades into darkness across unimaginable spans of time. Stars vanish, galaxies disappear, black holes evaporate, and matter itself may decay. What remains is a quiet, expanding cosmos where time stretches toward infinity, and the brilliant age of stars becomes only a distant memory of a once luminous universe.